So we're going to consider this function f such that x is converted into 4x plus 1 over 2 minus x. First of all, we're going to determine the equations of the asymptotes. And so the equations of the asymptotes, so for part A, we're going to look at the vertical asymptote first, because I always find that one of the easiest ones. So we want to see the vertical asymptote. And the vertical asymptote, as you would remember from page 1, occurs where the graph is undefined. And the only place where the graph is undefined is when the denominator equals 0, because you cannot divide by 0. So to find out where the vertical asymptote is, we're going to set the denominator equal to 0 to find out where that occurs. So now we just solve for x, and we see that 2 equals x. So the vertical asymptote is at x equals 2. Now, the other asymptote we're going to find is the horizontal asymptote. And like we just found on the other page, the horizontal asymptote is a ratio of the coefficients of x. So as x gets really huge, y is going to be approaching a value where we have 4x over negative x, because this positive 1 and this positive 2 won't make any kilobeans difference to the outcome. So as x gets really big, the horizontal asymptote approaches negative 4. Or sorry, the horizontal asymptote would be negative 4 because the graph is approaching negative 4 as x gets really big. Now we want to state the domain and range. So the domain comes directly from looking at the vertical asymptote. So the domain is x, all the set of x values, such that x cannot equal 2. So that comes directly from the vertical asymptote, because we found the vertical asymptote, which is where the graph is undefined. So if the graph is undefined at x equals 2, then that means that the value of x equals 2 cannot exist for the domain of the function itself. Then for the range, we look at the set of all y values such that y does not equal negative 4, because the graph will approach negative 4 but never touch it. Now, we can do this part C algebraically, but I prefer to do it graphically. So we're going to leave C until after we sketch the graph. Okay, so let's jump to D and find the axis intercepts. So we've got the two axes, the x-axis and the y-axis. We need to find the x and y-intercepts. The x-intercept would be where the graph cuts the x-axis, which is where y equals 0. And the y-intercept is where x equals 0. So for the x-intercept, we set y equal to 0. So this part, the left side of this equation, is equal to 0. So we're going to have 0 equals 4x plus 1 over 2 minus x. Now, in order to solve for x, we want to isolate for x. So we'll multiply both sides of the equation by 2 minus x. And when we multiply by 2 minus x, the reason why we're multiplying is because this is being divided here. 4x plus 1 is being divided by 2 minus x. So we're going to multiply both sides by 2 minus x. And then that means 2 minus x divided by 2 minus x. We have the same top and bottom, which means that that's just going to be 1. So then the result then, and 2 minus x times 0, anything times 0 is 0. So we're left with 0 equals 4x plus 1. And now we just take this and we solve for x. So we're going to subtract 1 from both sides. So we get negative 1 equals 4x. Divide both sides by 4. So x equals negative 1 over 4. So that is going to be the x-intercept at coordinates negative 1/4 and 0. For the y-intercept, we're going to set x equal to 0, so we're going to put 0 in for all the x's in the equation, in the function. So we got y equals 4 times 0, which is 0, which leaves just 1 in the numerator, over 2 minus 0, which is 2. So the y-intercept is 0 and 1/2. So now, I just wanted to check the equation here. So now what we can do is we can place the vertical and horizontal asymptotes on the grid. We can plot the x and y-intercepts. We can sketch the graph, and then we can discuss the behavior of the function as it approaches the asymptotes. So let's see if I can get the lines to work for the asymptotes. So we'll take a line, make it, green, and we'll make it thick-ish and a dashed line. And so the vertical asymptote is when x equals 2. So I'll just draw this hopefully as straight as possible. So that is the vertical asymptote, and we'll label that as x equals 2. And then the horizontal asymptote is y equals -4. So I'll again draw a line here. And horizontal, let's make it mauve, if that's mauve. And that's at -4, I believe. Make it as horizontal as possible. And then I will, does that work? I don't know. No, make it, there we go. And so this is y equals -4. Okay, so that's all fine and dandy. So now what we'll do is we will plot the x and y intercepts. And the x-intercept is -1/4. That's going to be fairly challenging to plot, but we'll plot it about here. And the y-intercept is 0.5, so we'll plot that here. And so then all we need to do is we need to sketch the graph in nice curves. So we've got 2 intercepts, and we've got the, whoops, if I can undo that. Great. We've got the 2 asymptotes. So if we know that the curve is going through the 2 intercepts and then approaching the asymptotes, we know that the curve has got to be going something like this. And going through those intercepts and approaching the horizontal asymptote like that. And so then if we take a look see where the other branch is, well, if the other branch were here, of course it would be approaching both asymptotes, but we'd get a second y-intercept, which we don't have. We didn't calculate a second y-intercept. We just calculated this one. And so it can't be in this area. And same thing up here, we could draw another arm up here. It would be approaching the vertical asymptote here and the horizontal asymptote there, but it would be cutting through the x-axis here, which would be giving us a second x-intercept, which we did not calculate. We only calculated one x-intercept, which means that the graph cannot be up in this branch. Therefore, the second branch has to be, whoa, that's not very good, has to be in this form here. Actually, you know what? I'm going to delete that. Okay, try this again. It's going to be something like this. I don't know if that was much better. So because there are no other asymptotes and no other intercepts, and it is approaching the 2 asymptotes. Okay, so now we'll go to part C, and we will take a look at the graph, and we will look at the behavior of the graph as it approaches the asymptotes. So for the vertical asymptotes, or the vertical asymptote at x equals 2, as x approaches 2 from the right, so as x approaches 2 from the right, we see that the graph is approaching negative infinity because it's going down as x is going towards 2 from the right. As x now approaches 2 from the left, over here, x is approaching 2 from the left, we see that the graph is increasing. Therefore, the function y is increasing positive, approaching positive infinity. So that's for the vertical asymptote. For the horizontal asymptote now, as x gets really, really big in the positive sense, as x approaches positive infinity, we see that y is approaching negative 4 from below. And as x approaches negative infinity, in this manner, y is approaching negative infinity, negative 4 from above. Okay, so this is how you would discuss the behavior of the graph around the asymptotes. So that is the lesson on rational functions. Here is your work. It doesn't look like a lot, but it's a fair process because we're doing all this process 3 or 4 times. So please start working on that, and you can work on it actually in class. Maybe take a look at it tonight after you go back to these examples in the textbook, after you do these investigations. Then in class tomorrow, come to class to work on these ones. So thank you very much for your attention, and we'll see you in class.